I wanted to take a minute and say thank you to everybody who has contributed to the GoFundMe project for the Akimbo so far. It's been really overwhelming and way more successful than I had anticipated. So thank you. And I'm going to include a little bit of where the update on where the design is and where the project stands at the moment. And I think I got the spring issue figured out. It may take a little tweaking, but it works at the moment, and I think it works well. There's a little added bonus that it may increase the safety factor, and I'll show how that works. Alright, thank you again. So here, what we have are the two prototypes I have at the moment. This is on the right here. It's the previous version. It's got the roller on the bottom. As this pin is a friction pin, and this eccentric pin is the adjustable friction pin. And then it has a roller here on the inside. And the purpose of that was in slack tending. You can see the rope channel runs through here. And this roller will contact the rope only when the rope is being, or when the Akimbo is being lifted by the shackle here. So it really kind of served a limited function. It was more of a leftover from the previous designs. So Dave McNeil had a really good idea of replacing this roller with a cam and then spring loading the cam such that it pushes the cam into the rope at all times. So there's always contact here no matter how loose you're setting on the adjustable pin. So this is the sort of quick and dirty version that I came up with to test that, and it works really well so far. So what I did is I built a cam. This is a teardrop shaped cam. Cut a slot out of the center so that I could put a spring on the shaft here, and then installed a pin, which is crooked because I was sloppy drilling the hole. But anyhow, the pin serves two functions in this prototype here. One is that it gives the spring something to push against, and the other is by fitting the pin in a notch on the back side of the cam, it limits the travel of the cam. So what happens is, if you can kind of see, this side plate is from previous version. So this cutout shows the position where the friction pin was previous. So what I did is I set this so that when it's loaded, the cam stops in the same position as that pin was previous. So the friction and the function is the same under weight, but this springs up and pushes against the rope when it's not under weight. So here I've got two different size ropes, pretty much the extremes of the arborist rope spectrum. I've got the good old 1/2 inch, and then this is a 8mm line from REI. And the Akimbo, so far I have not tested it on a rope this small. It works on 11mm Safari. I kind of doubt that it's going to work on an 8mm as it is now, but like I said, I haven't tried it. This is the only piece I have, that small rope. So here we have the Akimbo on the 1/2 inch rope. And under load, the rope, squashes a little bit and rubs on the side plates as it is. My plan is to have the side plates milled out just slightly, a 1/16 of an inch on each side, and that'll give a 1/2 inch plus 1/8 of width to the rope channel in the final version, which will make it work much better on these larger size ropes. So I don't know if you can see the cam in there pushing against the rope, and then when you load it, the cam is pushed down into the stop position and just functions as a friction pin. And then when it's unloaded, the cam is pressing against the rope and holding the whole thing in position, but not so tightly that it can't function. So here it is on the 8mm. and it seems to grab. I mean, when I pull on it, I'm not hanging my full weight on it, of course, but it does grab, so maybe it does work. I don't know. But in any case, you can see how the spring holds the cam against the rope and keeps it in position on here. Possible safety feature here is what happens when I set the cam, the adjustable pin, when I set it to a very loose setting on the rope, say one that's too loose to function on the rope, instead of slipping down the rope, what happens is the cam now has enough room with a loose setting to move upwards, and it pinches the rope into the cam and sort of jams the whole upper arm and locks it in place. So if you were to accidentally set the rope to a setting that was too loose, or possibly if the indexing pin here were to break, it would simply lock on the rope rather than sliding down in an uncontrolled way. And that would be really cool because safer is better. So now I've switched it to almost the loosest, not quite the loosest. And you can see the spring is still causing it to engage. And when I pull, you see how far up that cam travels? So it's not, let's see if I can get this to where you can see it. It is not down here where the friction pin was riding. It's way up there. And what it's done is it's jammed and sort of locked the rope in place, which I think is a really awesome accident. I would much rather have a situation where it locks on the rope than a situation where it slides uncontrollably on the rope. That's where I'm at right now with the process, and I am working on the CAD files for this spring mechanism, this cam, and the cutouts for increased size to the rope channel, and then just getting all the hardware figured out, which is an adventure in and of itself.